do we define a metre?
A big stick.
I'm not kidding. A big stick really was the start, anyway, of the official definition of a metre. So, back in 1791, the metre was first defined as 1/10,000,000th of the shortest distance between the North Pole and the equator on a line that passed through Paris. I mean, that's great and all, but someone's gotta go measure that distance. Thankfully, you don't have to measure the full distance of it. You can just measure a section and then extrapolate, at least as long as you know the angle of the section that you've measured compared to the 90 degrees from the North Pole to the equator. That meant that by 1799, the French had their official definition of a metre, and it was represented by, you guessed it, a big stick. That was then the standard that everybody else had to define their metre by coming to Paris and making a copy of the big stick that you could then take home with you. The problem with that is that you're never going to make a perfect copy. You're always going to have some slight differences, and tiny differences on small scales balloon very quickly on large scales. It's also not a very useful definition because it's not reproducible anywhere on Earth, or thinking bigger, anywhere in the universe, unless you have the original big stick with you. So the first attempt at standardising the definition of the metre was in 1960, when they finally did away with the big stick in favour of a krypton atom. So when electrons in atoms gain energy, they can use that to jump up one level, orbit a little bit further away from the nucleus. And then when they drop down to where they should be, they give that energy back out as light at a colour or wavelength that is unique to the energy difference between those two electron orbits, and therefore unique to that specific atom wherever you are in the universe. Krypton gives off a nice orange glow that's the same everywhere. So in 1960, the metre was defined as the length equal to 1,650,763.73 wavelengths in a vacuum of the light corresponding to the transition between the levels 2p10 and 5d5 of the Krypton 86 atom. Is that better than a big stick? I don't know. But then the laser came along, which made for even more precise measurements of both the speed of light and wavelengths of light. And knowing the speed of light to a greater degree of accuracy meant that the metre could be defined more accurately based on the speed that light was travelling, more so than trying to measure the wavelengths of light from a krypton atom. And so in 1983, the metre was redefined as the length of the path travelled by light in a vacuum during a time interval of 1/299,792,458 of a second. Essentially, instead of trying to measure the speed of light, we've now defined it, and we measure the metre based off that so that we can define a metre wherever we are in the universe. But if you're also now wondering, well then how do we define a second? Check out my previous video on just that.